Yeah, this is Raghu Bala with your Module 2 Roundup video. So this week we covered the topic of machine learning. So firstly, we'll begin the definition of machine learning, which was given to us as machine learning as a discipline that tries to design, understand, and use computer programs that learn from data for the purposes of modeling, prediction, or control. So in the case of prediction, we looked at predicting, let's say, a stock market or collision avoidance or certain types of medical events, catching a particular disease, stuff like that. And then in terms of, the example given was how to predict whether someone likes a movie, and then we used concepts from linear algebra to model what we call a feature vector. And those who want to get further into this discipline of machine learning, linear algebra is very important, usually taught in high school or even early stages of college. But that's a key topic that is used by most of the machine learning programs, whether it be MATLAB, Octave, things of that nature. Even in Python, you need to know linear algebra. So that was what Professor Yakula's videos, he represented that as data. All the features were represented as linear algebra matrices. And then in machine learning, what you do is you have a training set, which is the set of data with which you train your algorithms, and they learn from that. And then what you do is you have your test set, which is the set that you test your system against. And one of the things I wanted to say is um, machine learning is a ongoing process. It requires a feedback loop. So if one thinks that I just punch in some data and then out comes something, the output, and that's not the end all be all. Usually it's a feedback loop where you take the learnings from one set of outputs, and then see how it performs in the real world, and then go back and iterate one more time. And that's how a system keeps on learning, which is why we call it machine learning. It's not you learn it once and done. It goes round and round, so to speak, and then it gets more and more accurate. Now, in terms of machine learning itself, there are different forms of machine learning that we went into. First one was supervised learning, and then there was a graph shown to classify sort of hits and misses in supervised learning. And then examples were given as far as classifying images, such as a mushroom was presented, some cherries, pictures of cherries were presented, and so on. Now, in terms of other types of more deep learning algorithms, we very briefly covered convolutional neural networks, recurrent neural networks, and so on, where edges, parts of objects are seen, and then we specify layers of transformation from small features. Um, Next is, this type of technology is actually used in scene analysis for self-driving cars, for example. And a number of companies are doing a lot of work in this area, in the Bay Area especially, where a lot of research is going to self-driving cars. Example, Uber, Waymo, and Apple and others. Uh, then another example was using machine learning for translation of language from English to Spanish, and stuff like that. And then also we talked about chess, the game of chess versus game of Go, um, seeing how one is more complex than the other and how data can be represented. For example, the visual representation of a Go board, how it's a combinatorially a more complicated problem than actually chess, and how a machine can be taught to play Go. In terms of other types of learning, we also talked about unsupervised learning, and then reinforcement learning. So reinforcement learning is almost like the mice and the maze, or Pavlov's dog theory, where you ring the bell and the dog is fed, and after a while it begins to reinforce this behavior. Whenever a bell is rung, it starts to have hunger pangs, and it knows that food is going to be served and things like that. So So it's kind of similar here, where a mice is trained to go through a maze to find a piece of cheese, and it begins to soon figure out which are the dead ends and how to get to the cheese. So reinforcement learning follows broadly the same sort of principles, actually. And then there was a question about what cannot be machine learned, and chaotic processes cannot be machine learned. Sometimes, I think the example Professor Yakola provided was to do with more nature-oriented things, where where there's a certain amount of predictability. I think he said about something about space. Yes, his example is about space, where the movements of planets or asteroids and things like that are less predictable, chaotic in essence, and cannot be machine learned. Now, two ways of using machine learning. There's both sensing and predicting. And in the sensing bucket, a few examples were given: shoegazer, telescopes, a mobile eye. These were in the text of the particular topic. And then in the prediction bucket, we had predicting financial fraud, disease, mechanical failures, crop yields, and so on. And then the examples of I think Group AXA and PayPal for fraud detection was presented as material in the text. And then also a couple of other examples. Professor Alex Pentland talked about how Cogito was taught about attenuating its tone and voice and gestures to increase customer engagement, or at least giving feedback to the human, in the form of when to add certain words, or set a tone for a conversation so the engagement improves. So here AI is acting like a assistant to the human. And then in terms of personalization, we've all seen this, like Netflix and also Amazon. They have recommendation engines. And then one example is given the text on Stitch Fix for clothing. And this week we saw a number of good posts, and I'm not doing justice to all the students, because many of them have posted several good articles, and I am gonna just pick three out that stood out to me. But then many more good ones in the mix in this module. So Jose Manuel Barros Saez, he has posted a lot of good links and articles, and one of which would be very helpful to everyone involved is the machine learning canvas. I'm going to include it with the post to take a look at it. It's a kind of a tool that you can use for your individual projects. Another one is Hendrik Dietrich, and he posted an article which was recently in the news about the role of quantum computing in deep learning, and in Google's claim to have achieved quantum supremacy. I think it's somewhat premature, perhaps, because there are a number of players, including IBM and others, who are also trying to compete in this field. But definitely take a look at that article. I'm going to post it as well. And then finally, Robert Keogh included a PDF from Accenture Labs about explainable AI. I'm going to include that PDF with this post, because some questions have come up as to, like, how does AI become explainable? How do we know that the outcomes that it predicts, what's the origin? Why did it reason something in a particular way? So hopefully this PDF that I'm going to include will help you in that learning process. So with that, we conclude module 2. On to module 3 next week, which is natural language processing. Do keep the posts coming, and engagement is the way to go. It's the best way to learn in this course. And look forward to your homeworks, and have a good week ahead. Thank you.